For this recording, sizokhuluma question 3, physical properties of compounds. Alright, so the description box uzothola links for other recordings. So your physical properties include into ezifana nabo vapor pressure, melting or boiling points, intermolecular forces as well. Right? So we have van der Waals forces, the dipole, and London dispersion forces, as well as hydrogen bonds. That kind of discussion, physical properties with. Alright, so for 3.1, bafuna si define what is meant by a boiling point. Boiling point is the temperature at which the vapor pressure equals the atmospheric pressure. The atmospheric pressure. That's 3.1. Okay, that's the definition for a boiling point. Then sizalagu 3.2, Weber T. Okay, this is an interesting one. Group 17 on the periodic table forms diatomic molecules. F2, Cl2, abu I2, abu Br2, bromine 2. So dipole molecules, it's basically gases. They cannot exist as lone particles. They have to bond to provide the stability for compounds wakhona. So like 3.2.1, but what type of intermolecular forces will there be between molecules? These molecules, the F2 and the Cl2, what type of molecules are there? Sinama London forces. So, as I've mentioned before, we have 3 types of intermolecular forces. We have the London forces, which are the weakest ones. Siba nama dipole, as well as hydrogen bonds. So dipoles, the London forces, swathola more especially diatomic elements. Diatomic molecules. So with 3.2.2, which one of the following halogens will have the highest boiling point? Cl2 or I2? Just think about it. This topic is a topic also we discuss even now grade 12. So the answer lies I2. On the follow-up question, they want us to explain. I explain manje. But anyway, bafuna si explain why we chose I2. I2, uma ubheka on the periodic table group 17, Cl is just above I, right? The chlorine is above iodine, right? So the iodine has more molecular mass than a chlorine. So as the molecular mass increases, so does the strength. So does the strength of intermolecular forces, right? So that's the strength of intermolecular forces. So an increase in intermolecular forces, it means what again? As the molar mass increases, so does the strength of intermolecular forces. Therefore, maybe we can continue and say, therefore more energy is required to break the bonds. So this is the reasoning behind the choice, right? So for 3 marks, I think there's keywords. Intermolecular force increases, so does the molar mass increases. Another keyword. Intermolecular forces touch on energy. So 1, 2, 3. Yes, I'm satisfied. Then let's go to 3.3. 3.3. Study the following substances. We have hydrochloric acid, chlorine, NH3, CbS7 is CO2, Ca, calcium chloride. Which one? Okay, it's a 1 mark. Okay. All right. So which one? Okay, which of the above will have hydrogen bonds? Nope. Nope. This is the one with our hydrogen bonds, right? Is the one with our hydrogen bonds. NH3. Okay. I'm trying to come up with an explanation as to why I'm choosing this one. Okay. So phakathi chlorine ne Cl. No, not chlorine, nitrogen. Phakathi nitrogen nale chlorine. Which one is more electronegative? Okay, I'm checking a periodic table here. I'm gonna put up my values just now. Let me use a black pen. Alright, so let's check in nitrogen. Nitrogen, electronegativity yakhona is 3. Chlorine, it's also 3. Okay. It's also 3. Is that true? 3. Nitrogen, and then C1 chlorine. Okay. Let me say this. Beg. Okay, the answer lagu 3.3.1, it's actually the the ammonium, right? It's the ammonium. Beg. So the nitrogen is bonded to how many hydrogens? 3 of them, like this, right? Like this. So the nitrogen is about more negative than the chlorine. Why? Because of it attracts more electrons from 3 hydrogens than the chlorine, which is pulling 1 electron from 1 hydrogen anyway. Yeah, so this provides more spatial distribution of charges between the hydrogens and nitrogen. So this one is strong negative compared to the chlorine on the other compound, the hydrochloric acid, right? So having hydrogen bonds, swathola kuphi la ku ammonium, because of this spatial distribution due to the nitrogen attracting more electrons than the chlorine lapho ku hydrochloric acid. Dipole forces, swathola kuphi? So lana, let's say hydrochloric acid. So the answer here should be hydrochloric acid. So there's dipole la. Ne? Dipole. Okay. Lawa manye nyawa exclude. Carbon dioxide, it's like this. O, carbon dioxide. Similar to this one, it's gonna be something linear. Lana, as explained before, sinama London dispersion forces. So the only solution having dipole, it's this one. Because of the hydrogen, it's gonna be positive because the electron is moving towards the chlorine, and then the chlorine iyoba slightly negative, right? So kuba that dipole, meaning that one end iba slightly charged and then the other end iba slightly charged with opposite charges. Okay, so that's our dipole substance, a substance which has dipole forces. Okay, I hope we enjoy this question 3. Maskhulume in the comment section. Check out the description box for more content as well. If you like the content, please consider subscribing. So for now, signing out. Asponane on the next recording. Bye bye.